So I don't have a lot to tell you about galactose metabolism, so this will be pretty quick. So galactose is principally ingested as lactose, which is a disaccharide of galactose and glucose. The disaccharide lactose is digested in the intestine into its monomeric sugars, galactose and glucose. Galactose is subsequently taken up by the cell and phosphorylated to galactose 1-phosphate. Similar to glucose metabolism, the enzyme is a kinase, galactokinase. Following phosphorylation, galactose 1-phosphate is activated to a uridine diphosphate sugar. That's shown here as UDP glucose. The enzyme responsible for this, or galactose 1-phosphate uridyl transferase, is referred to as GALT, or GALT. This metabolic conversion can subsequently use the UDP glucose for glycogen synthesis, as we've seen previously, or it can be converted directly into glucose 1-phosphate, which can then be converted back to glucose 6-phosphate, where it can enter the glycolytic pathway. In this panel below, you can see how the metabolism of galactose parallels that of glucose, where glucose again comes into the cell and is phosphorylated to glucose 6-phosphate. It can be converted into glucose 1-phosphate through a rearrangement, and then it becomes an activated sugar, UDP glucose, used for glycogen synthesis. It can also be used for the synthesis of lactose in the process of milk production. So our key enzyme of importance here is galactose 1-phosphate uridyl transferase, as deficiencies here will block galactose metabolism and result in classical galactosemia. The consequences of classical galactosemia are that of the elevation of galactose 1-phosphate in the liver. The impact of elevated galactose 1-phosphate in the liver are significant, as they inhibit hepatic glycogen metabolism and other pathways that require these UDP sugars. Individuals with classical galactosemia can also present with cataracts, which can occur from the accumulation of galactose in the blood, which is converted to galactol, or the sugar alcohol of galactose. The accumulation of this galactose 1-phosphate in the liver is especially toxic. It's also toxic to the kidneys and the central nervous system, and if untreated, this disease may be fatal. So let's ask the question, what is the most likely presentation of classical galactosemia? And more importantly, when are you likely to see the presentation of classical galactosemia? So if we remember that galactose is principally ingested as lactose, that would be found in our dairy products. Let's focus on milk. Milk is a primary source of energy for infants, and therefore, this presentation would occur very early. The absence of GALT activity can be detected at any time after birth, and it's essential to obtain results promptly because children with classical galactosemia can have life-threatening crisis within the first few days. Infants with positive results are placed on lactose-free formula, and thereby removing galactose from the diet, you can alleviate some of the symptoms. Determining the activity of GALT is part of the newborn screening process.